Okay, so let's start this thing. So welcome everybody to our very first panel that we're gonna do in our podcast, and we're gonna try to record this in front of live audience here, and we're gonna try to record this hopefully in a way that you guys will all feel comfortable talking about the frameworks that you guys use on a daily basis. We're gonna try to also show the world that this conference that we're now attending can bring together experts in the field of Java and the ecosystem around it. We're recording this session at Make It conference in Portorož. The Make It conference this year is divided into two parts. One is more Oracle technologies, and one is what we call Open Blend with JCon, which is more Java and other technologies around it. So welcome everybody to this panel. We're gonna try to talk today about 3 Java frameworks, web frameworks. There are other Java frameworks that we talked about at this conference also. Sadly, we are limited by number of microphones here, but next year we might shuffle a bit. So sorry for everybody that use other frameworks. Let's put that constraint here. Let me first start by introducing our guests today. So here we have Roman Neglič. He's an independent contract and senior software engineer at a company called Object Computing Inc. Welcome.
Okay.
We then have Etien Rožnik from a company Sportradar. He's head of MBS shared services at Sportradar. I'm not sure what exactly that means, but I think you're an engineer, right?
Yeah.
Okay, check. And then on my left side, we have Gavin King. He's senior distinguished engineer at IBM and did a lot of stuff also from Red Hat, I imagine. Is that like
yeah, I work for Red Hat.
Yeah, okay. So that's why we put the IBM and Red Hat together there as well. You're also very known in the world of Java as a creator of Hibernate ORM framework as well. Welcome everybody to this panel. Feel relaxed, although there's a lot of people in the room. My very first question is going to be very hard, but still try to put yourself together to answer. So my first question to you guys will be if you can tell us a bit about yourself, the company you represent, and if you can tell us a bit what kind of challenges do you guys solve with your company so that we can understand what are you doing. I would start with Roman first.
Okay, my name is Roman Neglič. As you already mentioned, working in software development for almost 20 years. I can say that I have few points in my career where I really accelerate my knowledge about IT. First one was in 90s where I joined a Select Technology company, which does not exist anymore. And we were working on the Next and OpenStep computers, which are still considered one of the best object-oriented ecosystem. Then another boost was when I joined the Oracle company, working as a middle tier consultant, working on the project across Europe. See a lot of stack trace, see a lot of troubles, and learn really a lot. Then the third one was when I joined Micronaut. Actually, I used Micronaut already before, but I go deeply into the Micronaut when I joined Object Computing. So I'm not actually a developer of the framework, but heavy user. So I have constantly contact with the developers of the framework, and we're actually solving business problems and working on a business problem with Micronaut.
So you use Micronaut on daily basis?
Daily basis, yes.
Okay, thank you. Etien, can I ask you the same question?
Yeah, of course. My name is Etien, and yes, I'm a software engineer. I've been in the software development world for about 10 years, give it or take. And for the last 7 years, I've been a part of Sportradar. Over the years, I jumped over a few positions within the company, and with my latest role as the head of MBS Shared Services, I'm helping out engineers by providing various tooling, internet turnkey solutions, but I also teach engineers about frameworks and other similar things. So over the years, I've been in touch with quite a lot of technologies and open source solutions. And as such, I learned a lot of things, and that really helps me out from day to day.
Can I also ask you, you're gonna represent Spring Boot today because you also use it at the company you work for? Okay.
We're mostly a Spring Boot company, but we also use a couple of other frameworks, including Quarkus.
Okay, thank you very much. And Etien, can you?
Yeah, so I guess I have a pretty different kind of experience in the industry. I've been working in essentially the same role for 20 years now. And unlike a lot of folks in the industry, I have little experience of building applications and deploying applications. My workmates joke that I've never deployed an application in my life, and it's close to true. So I've been doing, tooling, framework, language, library development for, product development for my whole career. And it's interesting really when you talk to people, it's been interesting recently to really realize how kind of different that is. There's a lot of things which I'm sure everybody in this room, kind of lives and breathes and has lots of experience with. And if you ask me about it, I'm blankly, I don't know anything about what you're talking about, because the reality of product development is getting very deep in one kind of specific problem over the space of years, and kind of losing touch with the rest of the industry a little bit. Anyway,
specialist in one.
Yeah, I mean, the life cycle of developing a product is decade or more, and and that's longer than the life cycle of a typical kind of project, and in that time, that's plenty of time to lose touch completely with what the industry is doing.
Okay, so I do have like a couple of questions about trendy stuff. So if hopefully we'll get through that.
Hopefully I can cover up my ignorance.
Okay, let's go into more now the content of this episode, right? So we'll start with Roman, and we'll talk more about. My first question is going to be about Micronaut. You presented today Micronaut, and from other presentations regarding other frameworks, what stand out, at least to me, is that Micronaut tries to be polyglot framework, meaning that it supports several languages, but you also go very far in the sense that you demonstrated, for example, in your talk today, that matrix for all the documentation that you have. So all the languages that you guys actually support, there are docs written in detail for everything.
Correct. We are very proud of that.
And it's impressive. You also need a generator to generate the scaffolding of the tool because of the nature of that, right? So my question there would be, why would you build today a framework that is polyglot? What's the advantage? And
the first reason was that actually the origin of this framework and the authors of the framework comes from the Grails. So Grails was a framework, it's still framework, based on Spring Boot, but implemented in GraalVM. So that was the first reason why GraalVM was supported. And they have some problems with the framework, and they want to solve those problems. And they decided they will challenge those weaknesses of the framework and implement it on different way. So GraalVM was there. So what language could be better to start with than Java? It was in that time. Then Kotlin comes, and then it's normal transition to support Kotlin as well, because it's so compatible with between Java and Kotlin is quite easy to achieve. So that's the main reason.
There are three languages.
Three languages: GraalVM, Kotlin, and Java.
Okay. Yeah, that's what. Thank you for that. Okay, I'm gonna go now to Quarkus and Gavin. So that's a question for you. Some may say that like traditional stack, like having big monoliths, one application server that serves a lot of traffic, that these times are kind of like not suitable in this cloud environment where you have very dynamic loads, where you go into per request serving, all that stuff. We're moving more into this serverless ecosystem where you want to have small functions that spin up and scale down, all that stuff. So that's my hypothesis. Do you feel that that's still?
Yeah. So, I mean, look, I think, the whole, cloud deployments have clearly been extremely successful, to a greater extent than I had expected. Surely there's still, some organizations who want to run their cloud internally or want to, or who are, have, software that works on a, what you're calling a traditional stack, I guess, by which I take it you mean like a, like cluster of services serving HTTP and then a relational database behind it, something like that. I was joking last night that I've written code in Fortran for VMS. So, but so traditional is kind of new in a way. It's not that old. Okay. So that's been very, 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 very successful. And, and Java has been perhaps not, it was perhaps initially not a perfect match to that architecture because of the initial resource requirements of just spinning up a JVM and the latency involved in spinning up a JVM, and so I don't want to get too far down that path right now. When you're talking about serverless and stuff, I'm not really sure what word means. I kind of tried to ask folks yesterday what that means, and they were kind of like, well, and then they give me a textbook definition of what a server is. And then, but apparently the thing is, well, yeah, it's infinitely scalable and all that. And I just want to, kind of, look, I don't know, I'm talking out of my area of knowledge here, but I just want to caution a bit when we start talking about infinite scalability, there's this thing that happens in our industry, like, where kind of every 5 years or so, somebody discovers that stateless services are really scalable, right? Yeah. And right. And that's great, that's great that your stateless service scales. And that's really great until you have a program and you want your program to have an effect upon the world, right? And so when you're talking about stateless services, you're talking about pushing the limits to scalability somewhere else, okay? So as soon as you need to access a database, as soon as you need to cache some data, as soon as you need to divide up a workload into various parts which share some intermediate state between them or have some dependencies upon how the computation needs to proceed, or or more exotic things, you need to run a part of your algorithm on a quantum device. There's something like, I don't know, order 10 to the 4 qubits in the world at the moment, right? Mm-hmm. Or I don't know, you're running a shared world and you have players who need to interact. Suddenly, I don't care how stateless your service is, it's not infinitely scalable. Okay, so I know it's just picking on a word there, but I'm always a bit like I feel like sometimes we focus too much upon that stateless service without, and when we should, or we should be talking a lot more about state and how to manage state. And in these cloud, what I think is really exciting about these cloud environments is the extent to which is the advances which have been made in terms of scaling data, right? And workloads which I wouldn't have thought would be natural for the cloud, things in machine learning and stuff like that. Like naively, I would not have thought would be very natural. Like this, are moving to these kind of cloud things. I think yeah, I'll stop there.
No, it's fine. My question was more like, correct, I'll completely understand, but you have a feeling that Quarkus, the development of Quarkus, is focused around being ready for this environment, being ready for there is, you feel that it's tied to GraalVM, to native images.
Okay, so
we can talk more for other frameworks in this.
Yeah, well, I didn't want to cut into their time. So
yeah, that's fine.
do you want me to answer that question?
Yeah, please do.
Okay, so fine. So so we always want to, it's a difficult messaging job on our part. Okay, first of all, Quarkus is not only a framework for GraalVM.
Yeah.
Okay, or for a native compilation. Okay, it is the next generation of what was our server Java E technology. Okay, reinvented for the modern era. Okay, one of the things it does extremely well, and obviously a big focus of development, is that it is the need to be able to spin up instances extremely fast in a cloud environment, and that is enabled not just by native compilation, but more importantly, actually most of the work is not just on being able to compile for GraalVM, but in terms of being able to compile, interpret, and compile a bunch of metadata into the image that is deployed. So that if you start up Hibernate or something like that, you're doing that work at compilation time as part of the build step, rather than doing it at runtime. I'm going to cut myself short.
Yeah, okay, cool. Etien, you ready for next one?
Yeah.
Okay. My question is going to be regarding Spring. So Spring, you kind of feel that it has transcended the word framework. So it's more like the whole ecosystem of tools and services and libraries and cloud offerings, and there's a lot of stuff regarding Spring. So can you, like, from beginner perspective, explain to us the difference between Spring Boot and Spring Framework? Like, what's in the whole ecosystem that you're most excited about, and can you tell us a bit more about that?
Yeah, while the long answer would be very, very accurate, I would probably still forget quite a lot of things, because as you said, it is really a long list of features that the Spring Framework offers. So if we just sum it up, we can say that the Spring Framework has those functionality available and you can use them, but there is a lot of boilerplate configuration which you have to do. Whereas with the Spring Boot solution, a lot of that boilerplate gets done to the auto-configuration functionalities. So what that brings to developers is that developers can start doing their business logic way sooner than with the Spring Framework.
There's a Micronaut Quarkus. I think they promote themselves that they're AOT ready, meaning that you compile all these things in advance and that helps build native images and all that. Is that still the case also with Spring Boot? Do you use these technologies also there? I'm not sure if it's...
Well, to be honest, in the last year or so, I didn't give it a go with the Spring Boot AOT compilation. But last year, when I did the analysis, and I was comparing Quarkus against Spring Boot just wasn't there. But I know that since then, there was a lot of work done within the Spring Boot ecosystem on this. And the bottom line 1 year ago was that Quarkus is the clear winner for ahead of time compilation. And that was mostly because Spring Boot dependencies just weren't there up yet, at least for the stack that I was looking for, because I had a particular solution in mind that I needed to deploy in a serverless environment, and I wanted to do native compilations for the quicker bootstrap times. But yeah, as I said, that list of dependencies that are now being supported by Spring Boot is being constantly updated, and I would suggest to developers, when they're starting to think about going the Spring Boot AOT path, well, just check up that list and see if that list fits your needs and you have all the dependencies ready, because otherwise you're going to have to do a lot of manual work and configurations to enable AOT.
Okay, thank you for that. You guys all comfortable? You can also drink water, so relax a bit.
What a coffee, man.
Coffee.
Water stuff.
I'm going to go now into the next kind of like section of questions. And I'm going to go to Roman, to you. My question is going to be, modern systems now going more towards, event-driven architecture, microservices, and we need to then somehow connect these services together, etc. And my question is, or like an open-ended question is, can you give us some pointers, like how hard it is to use Micronaut in microservices way, and like how hard it is to couple these things, I don't know, together with some broker like Kafka or something? Is this part of the framework, or do I need to reinvent things around it? Can you tell us a bit more?
Actually, Micronaut fully supports declarative clients for the Kafka and other messaging systems. So it's very easy to implement. For example, just define interfaces, annotate with topics which you are using, which you are wanted to receive, for example, as a listener, and you will get messages from the Kafka. And put into the configuration a few lines where this Kafka server is located, and that's it. That's all what you need to be able to receive messages. The same situation is with producers. So we also support declarative producers, and you just call it. Thankfully for the IoT compilation, where when you build your application, all this code is generated for you, so you don't need to do anything about that. There is question if the event-driven architecture is the right solution for coupling microservices, because it brings some other challenges, how to handle all this, how to handle transaction, what to do with this. Actually, I prefer. There are other event architectures as well. For example, event sourcing is one of them. Event sourcing, I think, when you have one source of truth and just save events which happened in the past, and then recreate the state of the object from that events, and that's perhaps a more appropriate approach how to handle event-driven architecture.
Okay, thank you. It feels like it.
Maybe just one comment.
It feels too easy, you know.
Yeah, it's easy. But maybe one just comment about framework and IoT compilation. Maybe all this is obsolete because Amazon, I think, has this crack functionality. You know, when you just create an image from the Java process, and you just recreate it from it's instantly, you know, it doesn't matter if it runs Quarkus, Micronaut, Spring Boot, and
but what happens with
actually theoretically it's very good. I don't know practically because I didn't.
But what happens with, if we go back to what Gavin said, what happens with state? For example, you have a snapshot of, you know, current time.
Yeah. Okay. State is preserved, so you get the last state when you finish with your application. So I don't know if that's good or not. That depends on the situation, but it looks promising.
So my colleagues who've reviewed this quite carefully say not.
Really?
Yeah.
Okay.
Yeah.
I read about that. I never used it, but
I'm passing on that item of information,
sure.
but they
Sure.
Right, Alice? Yeah. They say no.
Okay.
It's an experimental world.
Yeah.
Thank you for your answer. I'll go back to Gavin now. So Hibernate is now 20 plus years old. Thanks for all the very hard work on that as well to you and your colleagues. My question is still going to be related to Quarkus more a bit. So is it today still a good idea to mix Quarkus and Hibernate together? Do you guys put a lot of effort into making it as easy as possible? Like, how does this chemistry work?
Right. Yeah. I mean, it's a great question. You know, like when I got, you know, got the call to work on Quarkus, you know, really the thing that stood out for me and why I'm, you know, not really doing data development on Quarkus, but really came back to Hibernate was really the realization that Hibernate and ORM was still super important to our you know, developers on our platform, and the other realization was that this project was 20 years old and had been very stable, and that meant a lot of cruft, right? Mm-hmm. So, you know, really, I mean, that was the what the question you just asked. Yeah. You just asked me was a question I asked myself 3 years ago. Was, you know, are we in a, you know, is this something that we can really now, you know, it had been kind of like in a maintenance phase as part of why, you know, as an underlying implementation of JPA and, you know, Wildfly and that was a question and really, you know, we had to sit down and look at it and go, okay, you know, we need to reinvent this because this is actually critical to what we're doing with Quarkus. It's actually really important. And the other side of this was that Quarkus, you know, we're kind of late to the game a bit with Reactive, but, you know, Reactive was, you know, an important thing they wanted to be able to support in Quarkus, and you know, nobody had ever heard of a Reactive ORM, right? So we had to make Hibernate Reactive. That's quite hard with such a big old code base, but we did it. And so that was a very, very interesting project. I mean, a kind of unglamorous project going through and trying to figure out how you can clean up all these APIs and fix all this craft and kind of
make it stable.
bug-like behaviors that are developed over time, and that, you know, without breaking everything, you know, every single program. Anyway.
But no, it's fine. I'm gonna do a follow-up on this question, and in this conference we heard talks about this project Loom. Like I went to a Scala conference, give a talk there, and there was like you know, people in Scala world are excited about Project Loom. So everywhere, to every conference you go, green threads coming in Java, it's a revolution. And it's gonna radically simplify, possibly even eliminate the use of reactive patterns in the code bases. That I think is gonna be challenging on its own for Hibernate, for Quarkus as well, right? Are you guys excited about it or scared?
No, I mean, I guess I got to agree with the Scala guys then. It's very exciting. It's very interesting. Again, some of the, we need to be careful about the hype. You know, I was just looking at a website which was saying, oh, this is going to mean your server can scale to millions of threads, right?
Yeah.
And once again, you know, I want to hammer on this fact that, you know,
be
right?
realistic.
That's not, be realistic here. You know, one of the things we've run into with Reactive is users coming on and wanting to use and saying, oh, everything runs on a single thread, so I can fork my Reactive stream and hit the database in 20 different threads, and it's going to be faster. And no, you can't do that, right? Reactive streams are a kind of thread. Okay, Loom virtual threads are a kind of thread. All right, if you have shared mutable state that is shared between threads, doesn't matter what kind of thread they are. Okay, thread doesn't mean native OS thread. It didn't mean that when the word thread was coined. Okay, and it shouldn't mean that now. All right. So if you have a multi-threaded program, multiple reactive streams, multiple virtual threads, whatever they are, and you share state between them, then you need to synchronize access to that state. You need semaphores. You need whatever it is, whatever concurrency management pattern you have. All right, and that means, you know, the idea, oh, you know, before I was limited to running 1,000 threads on and now I'm just going to run 1 million and I'm going to get that for free, is I would argue not right. We're going to have to think carefully about what the programming models are. We've seen that people immediately start abusing reactive streams in terms of data access. Okay, that's something that's like this crash between these two, my world and the world of people who are thinking about stateless services, and immediately they started abusing the model and not understanding that no, not everything is stateless. Particularly, you know, data access is not stateless by nature. So with Loom, there's lots of interesting questions. You know, does it mean that reactive is over? Unclear. I don't know the answer to that, and we don't know the answer to that. We're talking about a lot. You know, some of my colleagues think that the JDBC drivers, for example, will catch up really quickly, and then we're good. All right. Some of my colleagues say, well, maybe not. Right. And so, you know, maybe there's still a place for these replacement for the Vertex reactive database clients and stuff in all this. Right. You know, perhaps we'll be using Loom, but then we'll switch over to Reactive at some point. I don't want to go too far and start saying stuff that we're thinking about, right? So it's really interesting, and there's a lot of opportunities for us there. But we have to like really do a lot of testing and think hard about programming models, and it's very interesting, super interesting.
Just a question, you guys, your frameworks, do they depend on Netty or not? Can you?
You can't make them depend on Netty.
You can make them depend, but
actually not. We can choose the engine, the web engine. So we can run it on the Tomcat. We can even deploy it to the WebLogic server or something like that. So
okay.
You always have the option.
The same for Spring Boot. I tested with Spring Boot. It works.
But Quarkus,
Yeah, I think we're Netty by default.
Yeah. Okay. Cool. So the Netty is still the framework underneath the frameworks that you guys use on a daily basis.
Correct. It's the fastest way to.
Still. Okay. Cool. That was an easy question. Okay. I have the next round of more questions focused more towards like bringing these frameworks to the hands of let's say newcomers or beginners, or how to make these things more accessible to the new generation of the engineers, if you want. And I'll start with Roman with a question for you. For example, Micronaut comes out of the box with Open API, Swagger support, AOT compilation, aspect-oriented API. Yeah, just these are words that I got from the webpage. And it's a polyglot, etc. But the question here I have is like, how hard it is to go from, for example, the demo that you had on today on your presentation to actual production environment. Can you you have to do a lot more work than just like, does it help the framework?
Actually, no. Yeah. Gradle plugin, which comes with Micronaut, supports all kind of building deployment images. So you can build native image, you can produce fat jar, you can deploy, prepare Docker, you can deploy this Docker to the registry. So everything is actually quite easy to achieve. Then the problem, how to go to the production, is more, I think, what is your process? How your code is testing? From what stages to what stages it goes, and that's more important than how to prepare just binary. Binary is easy. Let's just run the script and that's it.
But you also offer support for different ways of injecting configuration, flags, etc. as well.
Correct.
You put a lot of effort into that. At least that's how I feel.
With simple definition of Micronaut environments, you said, for example, test whole different stack of configuration, application configuration can be used. So it's easy to set, for example, even it was deducted from the environment. So when you deploy to the GCP, it automatically, if it exists, application -GCP is used. So now I think in the new version is not that anymore, and you have to specifically define in what environment it will run. So from technical perspective, it's easy. I said what I mean is more hard is how to define the deploying process.
Okay. Question for you, Etien, then. Spring Boot has a very active community, and you also have courses, certification, academies also written on the page. There is a lot of resources around Spring, and would you recommend people doing any of that? Did you try it? You said did you also work with people? You try to introduce them to frameworks with juniors. Do you use any of these resources? Do you contribute to these resources? Is that the best way to learn, or YouTube videos or something?
Learning is a core skill that every developer should really work on it, because learning on how to learn new things is something that you master through your whole life. And every person has different requirements on how to learn new things. For some, it might be YouTube videos. For some, it might be reading a book. For some, might be attending a seminar or two in real life. Now, whereas the Spring Boot Academy, no, I didn't give it a go. And yes, I suggest to people to use online courses and YouTube videos or similar things to get a kickstart on their knowledge, so they at least get acquainted with the system, what is going on, a few concepts, the terminology, but that is only a baseline knowledge. From there, engineers have to build on. They have to get their hands on code or the keyboard, and they have to start writing code so they get a feeling about the framework, maybe write a unit test, an integration test, and really understand what are they doing, and not copy things just from ChatGPT or similar stuff. Because while that might get them through a few problems, at the end of the day, they are engineers and they have to build ChatGPT and not use it.
Thank you. You prepared for this answer. You can sense it in your voice. I have a question then for Gavin now. The question is more how to work with community, I guess, but how can engineers contribute to a framework such as Quarkus, or Quarkus specifically if you want? And can you give us a few practical tips where you think that people can contribute the most, and how can they be how can engineers that, for example, now use Quarkus be useful to Quarkus developers or engineers?
Yeah, I don't know how to answer this question because it's something I've often wrestled with.
What kind of
it's
help
hard.
would help you?
Yeah, I mean, like, you know, and this, I guess, because the thing is, like the thing that would really help is if the people who are core developing the framework, whatever is the library, had time to focus their energies on strategically important functionality and weren't absolutely overcome by a parade of small minor bugs, right? So really, you know, if you want to, you know, if you're a contributor and you want to like help this framework advance, like the kind of work that would most help is completely unglamorous bug fixing, right? The truth is that for obvious reasons, very few developers are really that motivated to contribute unglamorous bug fixes. And so instead, what happens is that people come along and they want to contribute some major piece of functionality, and that at times is great, all right. But you know, a framework, a library has a vision, a philosophy behind it, even if that sometimes is not necessarily that obvious to you know, there is always a set of belief and ideology behind it. That was the word I was looking for. And so very often we have people come in and rather than posing a problem, they propose a solution, right? And the solution goes against the ideology. Okay, and it is very hard for me as, you know, someone, you know, leading or whatever an open source project, it is very hard for, or maintaining, I think that's the right word. It is very hard for me to not just kind of knock that on the head as, no, that's wrong for all these reasons. I mean, you do have to try and explain to people why that's not going to fly, not what we're going to do. And that rarely goes over well, right? You know, so what I often try to do is kind of explore, okay, what is it, you know, what was the actual real problem you were trying to solve? The number of times, you know, in my life as a software developer that people come to me with a solution instead of coming to me with a problem, you know, and I have to kind of drill down and by the time I actually get and discover what their actual problem was, like they've had it with me because I've challenged all their ideas and they're upset with me, right? You know, and so, you know, like I often feel like, you know, what I want to know is what are your actual problems, you know, like instead of, you know, you know, understand your problem better and then come and, you know, and then talk to us about the problem. And you'll find when you come to us with problems, we're like super interested to know about new problems if we didn't know the problem before. And then, you know, maybe we can work with you to design a solution which is coherent with the ideology and which fits with the other features and which, you know, can elegantly integrate with other things. Okay. I'll stop talking.
So, no, that's nice. So, people should bring problems to you, and they should fix bugs. Essentially, that's the right.
I mean, fixing bugs would be great. Like you laugh, but like that's actually what your average open source project needs is people doing unglamorous fixing shitty little bugs, right? Like, I'm sorry.
Yeah.
That's
And
what would help most.
That's how they would also learn the framework and understand.
Yes, and learn how and learn. Yes, right, and learn the ideology. Learn the
And solving bugs is hard.
Yes,
so
solving
people
bugs
get
is
out of them quite a lot.
But people should also like try to put more effort into reporting bugs. Like put more context into. Be friendly. Respect people's time. People on the other side are sometimes paid, sometimes not paid to
the quality of how you report the issue which you're facing makes an enormous difference to how quickly you will have a solution. And really, folks, probably not you guys in this room, but the typical quality of a bug report I typically receive is abysmal. All right. Abysmal. Wait, what is that word? Abysmal. Bad.
Well, these are more or less my like these are the questions that I prepared for you guys more or less, but I still have like the last round of questions for you. My question is like, can you name like one of the features that excites you the most in Java ecosystem and such, right? So what are you really looking forward in Java now and in the future? Like what excites you? So please, Roman.
This tough question. What excites me, as I said, I really love domain-driven design, and so environment, so event sourcing and that kind of things. I'm working on to provide a component for the Micronaut to be part for the event sourcing to be part of the framework. But I'm on the middle of the work, so that's my actually exciting idea.
Absolutely. Can I ask you a question, Sam?
Yeah, but we already touched my favorite thing of Java in the upcoming years, months, and that is Project Loom. Yeah. I'm hoping that this will at least severely decrease the complexity that we have to do today with the current threading model in JVMs.
Okay. And Gavin, can I ask you the same question?
What's the question?
What excites you about Project Valhalla?
What excites me about Project Valhalla?
Valhalla. That's a tricky question. Sorry.
Like
yeah.
Oh, well, that's pretty cool. I don't really like how they. I don't look over. I haven't looked at the most recent proposals. There was some things that I didn't like about the proposal from years and years ago, but Valhalla.
Yeah, it's a
like it's the value type thing.
I'm a Scala engineer. I don't know what you guys are doing these days, but
yeah, no. I mean, it's good. I mean, yeah, like no. I mean, I think it's
names,
right?
names are really catchy. Valhalla, Loom, Graal,
it's absolutely true that one of the critical things that limits your options with respect to implementing some kinds of algorithms on Java is that every object requires garbage collection, right? So I mean, I think value types are like super important. But I haven't looked at the spec for probably years and years and years.
Okay, that was a tricky question. Not good from my side. But still, like, what are you most excited about the Java in the next couple of years? What excites you?
What excites me in Java?
not by.
Look, man, you realize I'm like gonna be turning 50, and like it's pretty hard for a 50-year-old man to be excited.
I did that. I definitely did that to myself. So, yeah. We were now kind of like ending our slot here and our time, so I'm gonna do the closing remarks now. So I would really like to thank first Make It organizers and sponsors, and then I would like to also thank the sponsors and Patreons and supporters of our podcast to Grodje. And I would like to thank you, Gavin. I would like to thank you, Roman, and I would like to thank you, Etien, for your time. We're gonna put links to your profiles in the notes, thanks everybody for listening, and thanks for being nice citizens, and thank you.
Thank you for having us.
Thank you.